Okay, continuing on with our exploration of fractions. If you would be so kind, please, as to turn to page 475 in your Volume 2 Go Math books. That's page 475, and we are going to be looking at Chapter 8, Lesson 6, Relate Fractions and Whole Numbers. So, let's see if we can't figure out what we're going to be doing here, and then see if it makes sense when we get finished. So we're going to locate and draw points as fractions and whole numbers on a number line, and then use models to write fractions greater than 1. Okay. Well, let's see what this looks like. Steve ran 1 mile and Jenna ran 4/4 of a mile. Locate 1 and 4/4 on the number line. Okay. So we're going to shade 4 lengths of the 1/4. Right, so there's 1/4, 2/4, 3/4, and 4/4. So we got that shaded in. And then let's get this labeled right here. So that's 0/4, 1/4, 2/4, 3/4, 4/4. So now we need to draw a point at 1. All right, that is what Steve ran. So for Steve, right here, I'll put him in red. So Steve ran 1 mile. Well, here's 0, there's 1. So he's right there. All right. And Jenna, we'll put Jenna in blue, ran 4/4 of a mile. Well, 4/4 is right there. They're in the same place. All right. So since the distance 1, well, and let's keep it with our theme here. Since the distance 1, that's what Steve had, and 4/4, that's what Jenna had. And at the same point, they are equal. So Steve and Jenna ran the, anyone? That's right, the same distance. All right, let's come up here and see what this is. If two numbers are located at the same point on a number line, then they are equal and represent the same distance. Okay, they are equal and represent the same distance. All right, let's come down here and look at this example. And then I'll give you some helpful hints along the way that will help you make sense. Complete the number line, locate and draw the points 3/6, 6/6, and 1. All right, so we know that divided into 6, that's 0. Then we'll go 1. Let's get with the same color that we need here. 1, 2, 3, 4, 5, and 6. So we need to locate these points. So let's go ahead and locate 3/6. That's right here. On this number line. And 1 is located here, and so is 6/6. They're both right here. So our 3/6 and 1 And hold on for the bell here. So the question, are 3/6 and 1 equal? Explain. Okay. No. The distances do not end at the same point. Okay, and that takes us right back up to what we saw up here. Okay, they are equal and represent the same distance if they are located at the same point. All right, here's 3/6, there is 1. So 3/6 and 1 are not equal. Are 6/6, which is right there, and 1 equal? And do they end at the same point? Well, the answer is yes. The distances end at the same point. End at the same point on the number line. So 6/6 and 1 are equal. Hopefully this is making a little bit more sense. I can tell you this. Let's go ahead and take a little side detour here, and let's look at 6/6. And later on, you'll find out that your teachers may say that fractions are division problems in disguise. Well, if we take 6 and we divide it by 6, we get 1, which is the same right there. All right. So, and we'll look at another example of this later on in this lesson. Let's go on to right here. The number of equal parts the whole is divided into is the denominator of a fraction. The number of parts being counted is the numerator. A fraction greater than 1 has a numerator greater than its denominator. So we have been used to seeing fractions where this top number, okay, this top number right here is smaller than the number right here. But now we're going to look at examples where perhaps the top number is actually bigger than the bottom number. 4/2. Now that is a crazy looking fraction right there, but we'll take a look down here and see how this works. So in this example, each shape is one whole. All right, so we have right here's one whole, here's another one whole. Write a whole number and a fraction greater than 1 for the parts that are shaded, and the whole thing is shaded. So there are 2 wholes, okay? We said 1 and 2. Each whole is divided into 4 equal parts. So 1, 2, 3, 4, 1, 2, 3, 4. So there are 8 equally shaded parts. 1, 2, 3, 4, 5, 6, 7, 8. So early on, remember, we would say that fractions that was part over whole. Now we're just seeing that the part over whole can actually be more than 1. And let me go ahead and change that. There we go. So right here, the part, all right, how many parts are shaded in? There's 8 of them. All right. How many are in each of the whole? All right, so here represents 1. All right. How many are in that? Well, there's 4. Now, again, fraction problems, or fractions are division problems in disguise. So we take this top number here, 8, and we divide that by 4, and we get 2, which is the number of shapes that we have up there. Okay? All right, let's see what we can do right here. There are 3 holes. 1, 2, and 3. Each hole is divided into 1 part. So see, we did not come in. We didn't come in like before and divide them into fourths like this. All right. We didn't divide them at all. Just like getting a pizza that's not been cut. All right. Each part is divided into 1 equal part. So there are 3 equally shaded parts. So it's again, let's look at our part over whole. All right, how many parts do we have shaded? We have 3. Now, if we were to come in here, for example, and have this, all right, then how many parts would we have? Well, then we would have 6. 1, 2, 3, 4, 5, 6. All right, but in this example right here, we have just the whole. All right, and each whole is divided into just the one section. All right, so we would write that as 3 over 1, or 3 ones. Or later on, you'll see we'll just identify it as 3. All right, so this is where things do get a little bit complicated. All right, let's actually take a look and see here. What would happen if we went ahead and divided this into halves, for example? Okay, so how many parts would we have? 1, 2, 3, 4, 5, 6. And let's look at one of those holes. How many parts are they divided into? Well, they're divided into halves, or 2. Okay, so 6 over 2. 6 over 2, what is 6 divided by 2? That's right, it's 3. Which is the same answer we got right here, which is the same answer that we would get if we did not have those division parts there. Okay, so what can we say down here? Explain what each circle is divided into 1 equal part means in example B. Well, the best way I can say it is that that 1 is the denominator, or the bottom number of the fraction. And how do you divide a whole number into 1 equal part? You do not need to divide, because, or we'll say you not divide, well, yeah, because the 1 whole is already 1 part. I know, this can get confusing, and with a few more examples and a few more days with this, it will all make sense. okay? Never mind the bell. As we continue on. So we're going to try this. Each shape is one whole. Write a whole number and a fraction greater than 1 for the parts that are shaded. Well, we kind of touched on that in this example up here. Okay, so how many of these do we have? We have 1, 2, 3, and 4. Okay, so that's what we're going to put right there. Then each part is divided into halves. All right, so 1 and 2, 1 and 2, 1 and 2, 1 and 2. So each one is divided into halves. How many total halves do we have? 1, 2, 3, 4, 5, 6, 7, 8. So 8 halves is the same thing as 4 because 8 divided by 2 is equal to 4. All right. Let's go ahead and get ready to do the show and share. And look for that on another video so we can go over those answers together.